meeting, and I'm gonna share my screen, welcoming you to this webinar, which is titled The Ultimate Fusion Extended Reality, where extended reality meets artificial intelligence. So I'm John Soldatos, scientific advisor at company Novax, and representing today XR 5.0 project. We are a team of researchers and scientists that we are collaborating in the scope of different projects that deal with extended reality. Today, you will see some of these projects presented in this webinar. You can see them on the screen: XR 5.0, XR to Industry Augmentor, XR 4ED, Master Project, and Motivate XR in addition to XR 5.0. So on the right, you see the agenda that we are going to follow today. You see that we have two main sessions. The first session is more focused on industrial applications. The second one, more on applications that have an educational focus, an educational scope. Of course, these boundaries are not very strict, but this is a baseline distinction between the two sessions. So in the next 2 hours, we will try to shed light in a very topical subject about how artificial intelligence can help drive the next generation of extended reality applications in different ways: content generation, personalizing content, generating models, and we're going to shed light on the interplay of these two important technologies. So without any further ado, I would like to give the floor to Professor Mariano Alganic, and the coordinator of the XR2 industry project. So I would kindly ask Mariano to share his screen and properly introduce himself and his project so that we start the webinar. And thank you very much all for joining, and we hope you're going to get a satisfying content. Mariano, the floor is yours.
Okay, can you hear me?
Yes, we can hear you.
Okay.
Can you share your presentation also?
Thank you, John. Well, good morning to everybody. I will share my presentation. Can you see it?
Yes, we can see the presentation, and if you put it full screen, I guess we will be able to see the presentation. Thank you,
Okay.
Mariano. The floor is yours. Introduce yourself and your project.
Thank you. Well, good morning to everybody. It's a pleasure to be here. And my name is Mariano Alganic, and I'm the director of the Laboratory of Immersive Neurotechnology at the Universidad Politécnica of Valencia in Spain. And we are, LENI is a multidisciplinary research institute where we are researching basically the psychology and the neuroscience of extended reality. So our scientific topics are presence, embodiment, immersive learning, etc. And we have made and we are making applications in health management and some other industrial areas. As John said, I'm the coordinator as well of the XR to Industry project. And well, it's looking for how we can enhance XR applications from a hardware and software point of view in order to better serve several industrial challenges. My talk is about how we can use virtual humans in order to characterize human cognition. And this is centered around the concept of extended reality behavioral biomarkers, what we have called in LENI XRBB. What is this concept about? Well, normally in health-related application, a biomarker is an indicator that is used to measure biological processes. So inspired by this definition, during the last 20 years, we are working in LENI in developing extended reality behavioral biomarkers that are a characteristic that objectively can assess and evaluate different indicators of, I will say, human cognition in response to extended reality replicas of complex social situations. To do that, we have a scientific rationale behind that, that in mental health is based on the different theories of computational psychiatry. When we are applying this concept in commercial application or research project in human resources, we are based on organizational neuroscience models, and we are talking about marketing or retail, we are talking about consumer neuroscience models. But what are XRBB? Well, as you can see in my screen, the idea is that we have a user that has several, different demographics, personality, psychological traits, and so on. And this human or user is interacting in extended reality applications where, he has having interaction with different contents, mainly virtual humans, that are simulating different complex social situations. While the user is doing that, we are gathering several information from the user. One of them is based on biosignals, like galvanic skin response, eye tracking, voice, body movements, and so on. And another important group is based on behavioral metrics that are gathering from the interaction of the user with the applications, like what are the decisions you are taking, what are the reaction times, and so on. All these biosignals are processed, and we transform these in features that are analyzed by machine learning techniques. And once we have that, we can obtain the different behavioral biomarkers. I will show you some examples, or we talk about some examples that we are using for that. And this is used in two ways. When we are talking mainly as an assessment tool, we are using that in order to have a report about different, emotional and cognitive characteristics, personality of the user. And when we are talking about learning, we are using these biomarkers in order to adapt in real time the contents so that the learning outcomes will be optimized in order to enhance the learning capabilities of these extended reality contents. As I said before, we have applied that in several research projects. Some of them are also commercial solutions in order to be applied in health, in human resources, or in sales capabilities. These are the extended reality applications that we have used or developed in several fields. But for example, let me show you, or let me talk you about a research project that we are developing, that is how we can enhance or train, assess and train the communication skills of health practitioners, in that case, psychiatrists and psychologists, in order to enhance their communication skills with patients. Okay, let me show you an example. For that, what we need is we need to simulate a patient with some mental health issue like depression or schizophrenia. And for that, we mainly need to simulate a patient that has these mental health problems. And once we are doing that, we need to obtain metrics that traditionally has been based on psychometric tests or self-reports. And but that's the problem is that, well, this traditional way of assessing the human cognition, that can be biased by the test, the self-reports, As you know, there is social desirability. You are answering what you think that the group is expecting that you answer. And sometimes we are using, tests that are quite hard to understand because we are dealing with concepts like, empathy or so on that sometimes are difficult. So at the end of the day, if we want to obtain objective and reliable metrics about trying to answer, for example, this question, how good were you empathizing with the patient? We need to rely in more objective human behavior metrics. And this is the idea of using extended reality behavioral biomarkers. And for that, we are obtaining sometimes direct brain activity, but mainly we are trying to understand how your brain is processing this information in order to obtain, indirect brain activity from the behavior and so on. So when we are talking about that, we need to go inside social signal processing, and we need to be able to track, process, to understand different social signals, like, for example, the voice, the utterance of the voice, the prosody, the eye tracking, the gazing, the body posture, facial expressions, and so on. So that's why we need to obtain in real time all this information. Then once processed by machine learning, raise different behavioral biomarkers about different relevant capabilities of the user, like empathy, like creativity, like emotional regulation, and so on. So, as I said before, these are the type of measures that we can gather, and these are the type of stimuli that we can gather. Here in my talk, we are focusing in immersive contents, and during our research project, we are very interested in behavior, in time reaction, in gazing, in body posture. Why? I'm not saying that we are not using psychophysiologic. I'm saying that we are trying to extract as much information as possible using that, because mainly every extended reality hardware solution has the possibility of tracking the gazing, tracking the voice, and the postures. And we are especially focused in using digital humans. Well, and this is a research area that we have been working during the last years, and we have put a lot of resources. And virtual agents can be defined in several ways, but when we are talking about these type of solutions that we are developing, we are talking about intelligent social agents. That is, we are developing virtual agents that are able to display a certain style of human social intelligence, what is related with the social brain. I mean, they have capabilities of having empathy or having theory of mind with real humans. That's the main goal we are doing right now. And when we are talking about digital humans, this is a very simple architecture of digital human. It is very important here is how the virtual human can sense, the context. Here is the actions that can be done. And during the last years, there has been a lot of technological advances with very interesting and high capabilities of closing this loop. But the main challenge remains here. I mean, this is related with the body, simulating the body, and this is related with simulating the mind. And this has led to several cognitive architectures, in order to simulate this mind. And well, during the last year, there has been several cognitive architectures that has been proposed, but mainly every cognitive architecture needs to provide information about how we can simulate the verbal behavior and how we can simulate the non-verbal behavior of the digital human. As I said before, during the last years, that has been interesting cognitive architectures. As you know, artificial intelligence has led to very interesting, capabilities in, for example, simulating the verbal behavior. And some recent large language model are able to interpret some emotional expression and to generate some empathic, responses like Hume. But the state of the art is that these large language models are black boxes. I mean, they are data driven. So you don't have control for non-standard samples. I mean, that is quite complicated right now with this commercial large language model to be able to simulate, for example, the way a patient with depression will talk about, and to control that, because this is what we want to achieve. Regarding nonverbal behavior, there has been several classical cognitive architectures that has been set up in the last, I will say, 8-10 years. But up to now, we lack of a general model for social brain. I mean, this architecture has not been able to generate a general model of artificial empathy. And this is what we are working on, and this is what I wanted to show you, to share with you. Regarding verbal behavior, we are adopting what we have called in Lenny hybrid empathetic framework, because the commercial open or private solutions are very excel in response expression. But up to now, they are not able to understand the emotional and cognitive nuances of the user that is interacting with the LLM. So what we are developing is what we call small-scale empathetic models. And these small-scale empathetic models are very stronger in fine-grained emotion detection and are strong in emotion cause identification, where the LLMs are weaker. That in order to have response generation, broad response, LLMs are very well positioned. So they are strong on that. So what we are using in our verbal behavior simulator is to use this hybrid empathetic framework. And for that, we have trained these small-scale empathetic models in order trying to simulate the verbal responses of different humans with different, cognitive and emotional characteristics. So when the user is interacting with that, what this SEMS is doing is to prioritize primary emotion. And using this emotion cause perception strategy, they are prompting the LLMs to focus on crucial emotional words that has been identified by our, small-scale models. This is the way we are, for example, simulating the way a patient with depression is talking about, in order to trying to simulate as much as better possible how the type of wording, the prosody that the patient with depression is using. That if you are talking with this virtual patient with depression, using LLM, you can talk about, everything, but very guided by this pre-trained, network that are in the core of guiding the verbal behavior. That is the semantic, the contents, and the prosody. Okay. And when we are talking about nonverbal behavior, that is, how we can simulate the way we have nonverbal behavior that is very important because it's responsible of around 70% of the social information that we are transmitting. It's transmitted with nonverbal behavior. And this is, at the end of the day, is, well, how we can simulate, the gazing, the facial expression, the body movement of somebody, what is interacting in real time with a real human. Okay, for that, we have used, as a general framework, the cognitive approach of emotion. And this cognitive approach of emotion, I don't have time to deep inside, but mainly what is claiming is that the emotions are a process of evaluation of the situation by an individual. And this is based on a model that is a component process model, CPM. And well, what our architecture, what has developed is this way, is that, well, our virtual human is able, to have information from psychological signals, but also eye tracking, voice, and several other verbal and nonverbal behaviors. And here's the loop that we are using. But in our model, in order to provoke the nonverbal behavior, the different configuration of this model are guided by several appraisal variables that are grouped in 3 dimensions. One of them is the text that has been, generated by the verbal behavior. The other one is states, in the sense that we can say to our model, well, regarding to that, you will have some type of this balance, emotional balance. For example, you will be a bit upset and so on. But also we can put variables in triggers, what we call triggers, that can modify your nonverbal behavior according to our model, in order that, for example, saying, well, you have to have a more gazing approach with the real human, or you have to move forward to the real human. So in that sense, what we are able to do is that this configuration evolves during the interaction of both the verbal and nonverbal behavior, and we are able to develop more social brain guided virtual humans based on the emotional and cognitive reaction that the real human is having while he or she is interacting with the virtual human. I think that I'm running a bit out of time, so this is what I wanted to share with you.
You can jump to the conclusion, it will help the time.
Okay, that's thank you for your attention.
Are there any questions for Mariano? You can. Yes. So Mariano, 2 questions, right? One question from the chat is, if your current model, if your model can be integrated with current large language models. One question, a second question from my side, if what you presented is research of your lab, or if you give these virtual humans, virtual agents, as part of the XR2 industry. And this question, the second question, is purposeful because, we are supposed, other projects to use, some of the projects are supposed to use your XR2 industry platform. So for example, can we use a virtual human to profile a worker in an industrial use case? What is the utility you are offering? So these are 2 questions, and then there is a third one, but let's start with these 2. First question is, if you can integrate the model with state-of-the-art LLMs. Second question is, how much of this is part of XR2 industry?
Okay. Regarding the first question, yes, absolutely. In fact, actually, we are doing that. I mean, what we have done is to train small scales models that are trained in order to be able to assess and to understand different emotional and cognitive aspects of a real human, and are trained in order to simulate the verbal behavior of somebody with, different emotional and cognitive. But this is used in order to track and to prompt, several keywords, so that we can prompt the large language model, commercial large language model, in order to enhance, the verbal, richness of your conversation. First question. The second question is, well, this research has been conducted in my lab. Some of them out of the XR2 industry. And right now we are setting up, open call during XR industry, and we are deciding what software components we are planning to integrate in the XR2 industry, platform. So this is under study. Perhaps we will integrate that in the project.
Third question, which is the added value of incorporating a virtual human in an application? What is the difference from, a chatbot with emotional intelligence? I don't know if Fridolin, you want to open your camera and give more details on this question. If you want, please feel free. Yes.
Sure. Hi. Good to see you again. Yeah, my question is about that. Where exactly do you see the added value of the spatial interface? A lot of it we can do with other technologies as well, on the phone, the chatbot, Siri. There are specificities, right, that require the embedding in the spatial environment around the user. But I would be keen to hear what you think, where they are.
Hear you so clearly, Mariano. Maybe you can try to speak again.
Sorry, I would change. Better, right?
I can hear you, Mariano, so you can answer.
Yes, okay. And what we have demonstrated is that when you have a high level of social presence, your behavior is much more natural than when your level of social presence are lower. So when you are, and the way of enhancing this social presence is using virtual humans with only not, realistic aspects, but mainly that show emotion, that show natural social brain behavior. So if we want to use these virtual humans in order to assess or to train, if you are able to simulate the social brain, what we have demonstrated is that it's a very interesting interface to obtain more natural and reliable metrics of the social brain. This is the main reason in order to use this technology instead of some other, technology like chatbox or the voice, only the voice. There is another question about how you can integrate that in mixed reality headsets. This is something also that we can talk and address. But mainly, regarding your question, this is the reason why, the main added value of using that.
Okay, so let's move to the next presentation. Also, and I think Fridolin and we will have the opportunity. I think Mariano will be around to revisit this at the end of the webinar, right? In the questions in the Q&A session, right? Sorry, Bezir, but we have to move on. Otherwise, we will be a lot out of time. But please keep the question for the discussion later, right? And yes, the next presenter is myself, so I'll try to be really quick so that we catch up some of the time. So I would like to share with you how we are using artificial intelligence and extended reality in industrial settings, in human-centered industrial settings, what we usually call Industry 5.0. So I'll start with an overview of XR 5.0 very quick, then give you some motivation on behind the integration of AI into the XR cyber representations. And then I'm going to focus on one of the many systems that integrate XR AI that we use. We plan to develop, or we are developing already in XR 5.0, which is extended reality and large language models integration. So XR 5.0, 25 partners project started earlier this year. So we are really at the first stages of development. We are applying extended reality and artificial intelligence in applications that are personalized to the human loop. Industrial applications, that's why you see different industrial partners here, like KUKA Robot, Siemens, TAP, the Portuguese airline, and so on and so forth, alongside vendors of XR solutions. Now, we've written some text, some articles. This is a blog on the general integration of AI and XR. You can indeed, you have many different ways, even beyond what Mariano presented, on integrated XR with extended reality with artificial intelligence in the industry. Here are some of the ways. One concerns, content creation. There is also a lot of human AI collaboration scenarios, especially if you blend with AI paradigms that foster AI and human collaboration. And also you can integrate AI to drive human-centric digital twins alongside generating data, since we always have a lack of data and we use synthetic data sets. Now, here are some of the pilots. So we have a KUKA Robots pilot where we are doing virtual commissioning and using generative AI in robotics. We have personalized XR representations in assembly lines. So there, the idea is that we develop virtual reality applications and augmented reality applications on Unity, using Unity and MetaQuest, where the content comes dynamically from a generative AI model through proper prompting. This includes an NLM. Now we've got a host of training use cases. So using extended reality to help the operator train themselves, to help the operators train themselves in a safe environment. So we develop XR applications on HoloLens and Magic Leap and MetaQuest. And in this case, we use AI to dynamically generate the content and the instruction so that this is personalized to the trainee. You want an experienced workers to receive different instructions from a green worker, for example. And this is again the idea of worker-centric aircraft maintenance. What we do here is that apart from the training, we use a human digital twin for automating a maintenance process. And again, the content there comes from AI, so we can generate dynamically different cyber representations of products, of processes, and of content. Now, based on these pilots, this is not an exhaustive presentation. We have more than 6-7 pilots in the project. It comes our motivation for XR LLM integration. So having seen that a lot of use cases want this dynamic content in the, generation and integration, we thought, what if we could have an LLM server with tailored content and retrieval augmented generation to use for dynamically generating personalized training content or even generating code, software, or generating 3D models. And now I'm focusing on this development that is done by our company in XR 5.0, and this is the LLM server part that is integrated with different XR devices. So it is based on state-of-the-art large language models like GPT-4o and Llama 3, but it also has a vector database with embeddings generated from proprietary industrial data, for example, manuals, and then we develop on top of this LLM pipelines, including prompting strategies. So what actually the user, understanding what actually the user wants, combining retrieval augmented generation on the vector database with the add-on industrial data, and generating a personalized response, textual or multimedia, that it is then projected on the virtual world, on the representation of the maintenance process or other training process. So key elements of our LLM engine is some prompt engineering, processing and understanding user prompts, what the user wants, RAG, and agentic infrastructure based on large language model agents, and then an API for training management, content management, or a control interface to the XR applications. This is the technologies we are using to develop this LLM server. As we see, GPT-4, of course, the popular LangChain and Llama Index. These are the initial models we are testing on, including GPT 3.5, but also GPT-4. And from the user perspective, how it works. On a training session, that's the simplest example we have. You can upload the manuals of the industrial training process. The documents are indexed, parsed by the agentic tools, and then you can write prompts and generate dynamically content on the manuals of the industrial use case. And this is how the different parts of the pipelines work, from the uploading and the indexing of the document, the generation of the text embeddings, till the production of the Q&A interface for the industrial worker. Again, this is not exhaustively what we do in terms of AI and extended reality integration. As we see, our use cases are quite rich, but I just focus on one specific part, which I think is trending, and it focuses on how to integrate generative AI, large language models, with the virtual reality or augmented reality applications for an industrial case. So I hope I covered some of the time, and I'm happy to take one question. Otherwise, we can leave it to the end before moving to the next presenter, to Panagiotis Karagiannis from the master project and from LMS laboratory. So, Fridolin, this question is for us.
Definitely, yes. So with your RAG experience.
Yes, to be honest, now, we are just starting the user tests, right? Actually, not with this LLM server, which you understand is more general, but with the customized systems. We have an industrial case with telecommunications equipment. So in another, in a different project from XR 5.0. So to be honest, we just started, user tests where we will audit, things like user satisfaction and overall improvement of the training. Other than that, our approach is whatever manuals you have for the training, right? We just upload them, right? So it might be some more expensive in terms of interaction, maybe some more expensive in terms of latency, and maybe paying some more tokens. But we don't think that this is a concern. What is the concern is mostly the user, satisfaction. But for this, it's truly not me that I have to test. I think we can't credibly answer this question unless we have some insights from the industrial worker. Yeah, sure. We can share, and also, we write papers about this. So now that we have your contacts, we will feel free to forward the first archive once we have it. Panagiotis, please, the floor is yours. Feel free to produce yourself.
Thank you very much.
Master as well.
I guess you can see my screen, right?
Yes,
you can
yes.
hear me and see me well? Perfect. So, hello, good afternoon also from my side. Thank you for the invitation. Thank you everyone for being here in this very interesting webinar. My name is Panagiotis Karagiannis. I'm a project manager in LMS, as mentioned before. LMS is the Laboratory for Manufacturing Systems and Automation in University of Patras in Greece. And our research activities are oriented in general around manufacturing systems and how we can, let's say, provide technologies in order to improve the conditions. And more specifically, the group that I belong to, led by Dr. Sotiris Makris, is the robotics group. We are focused on using robotic technologies, sensors, and of course, AI and virtual reality technologies in order to provide innovative tools to our manufacturing partners. As mentioned before, my aim here is to speak about master project. I guess some microphones are open. So I hope you can hear me well. Well, in a nutshell, let's say the vision that we have in the master project is to leverage the mixed reality ecosystem in order to provide innovative teaching and training tools for robotics in manufacturing based on an open XR platform that we also develop in the project. Which integrates key functionalities that we believe have a central role in this activity for the training of robotics. And the first one is how to design and implement safe robotic environments, how to program flexible robotic applications, and of course, the human is always an important player in this activity, how we can provide advanced and intuitive interaction mechanism between the human and the machines. Our aim also is to deliver training content on robotics. So we have, let's say, a double role, not the technical role, but also an educational role in the project. And this twofold role, I would say, is also reflected in our two open calls. The first one has been launched at the beginning of this year, and now during the autumn, the first applications, the first the applications from the first open call will start, providing their own additional technologies, enhancing our work in the OpenXR platform. And next year, we plan to launch a second open call that has a more educational character, that would enable the applicants use all these tools from the OpenXR platform developed by Master Consortium and the FSTP applicants in order to provide this rich educational content. This was the vision, getting a bit in detail with the objectives, trying to, let's say, make this vision closer to reality. We have 4 technical objectives. I don't want to get into much detail. Very briefly, these 4 technical objectives are focused on the OpenXR platform, the safety tools in order to program and interact the robots in safety conditions, innovative tools in order to program virtual and real robots to execute real operations. And the last is about the interaction of the XR systems. So you can see there's a direct connection of the technical objectives with the technical part, let's say, of the vision that I discussed before. And of course, we have one industrial and educational objective that are connected with the 2 open calls. The first one is to bring SMEs and startups that are working on XR technologies on board with us and give them the opportunity to use this open platform to enclose their own developments and provide them to the world. And the second educational objective is to create educational material based on these XR technologies. Here is a schematic of more or less what I have discussed before. The project has 5 pillars. The first pillar, as you can see in the orange box, is the platform. That the platform is enriched with the developments of 3 main technical partners of the project. Each pillar 2, 3, and 4 is dedicated to the other 3 technical objectives. And the last pillar is the provision, the delivery of educational content through the second open call experiments using all the material from the platform. So getting a bit into more details about the technical activities. In the center of all the activities, as you understand, is the Master XR platform. This platform has this system architecture that you can see here on your screen that give us the opportunity to create XR content, to upload it to this platform, to manage and deploy in devices, in different devices. It could be headsets or PCs and so on, to be used by trainees. Also has a system, a user management system to give the opportunity to different type of users do different activities. So apart from the system administrators, the users of this platform as the XR content creators, the trainers and trainees, and the, of course, system administrators. The XR content creators are responsible in order to prepare the education material. The trainers are the ones who should deliver this learning material. And of course, we have the students, the trainees, that can log in, let's say, to this platform using different devices, as you can see here, and consume, let's say, this learning material in order to enhance and improve their knowledge. There are different modules that compose this platform. The XR content creators are going to use Master Studio for Unity module, which has different features and tools developed by us, by the Master Consortium. And this is the tool that gives the benefit to the XR content creators to use all the AI features that Unity offers. So the platform will give them the opportunity to use in the content creation phase and embed inside their XR solution AI features using the scene loader module. The next one, the next module is the safety module. This is, let's say, responsible to offer a different set of tools to the content creators in order to give them the opportunity to create safety related material. We have different categories, let's say, about the safety features that we should address. The one is the alerting, to give the opportunity to provide alerts in case of a hazard, to train using a safe virtual environment to prepare the trainees for the real world hazards and situations, to provide safety guidelines. There are tons of guidelines related to safety, so we can give a few tips, let's say, to the trainees, but also have safety by design, which also covers the ethical aspects of this activity. In order to cover these features, a set of different prefabs have been developed. This can be, let's say, robot prefabs or assembly parts prefabs, simple prefabs, in order to populate, let's say, your scene, but also there can be training methods, there can be safety zones, ergonomics prefabs, more sophisticated, let's say, prefabs to be used by the trainees. Now moving on to the AI aspect, let's say, of this activity. Our aim here is to give the opportunity to make the life, let's say, of the content creator easier by giving him the opportunity to create the scene using simple words. So we have created a scene creation assistant that uses in the background, checks in the background the project, the prefabs that exist inside the project. There are examples inside. This model has been trained with examples in order to understand when the user says that I want to put one part on top of the other or next to the other, what this really means. When we speak about dimensions, the same. When we also the parts have been have connection points, so we can identify which is the top, which is the bottom, which is the right, and which is the left side of a specific component. And of course, there is an LLM editor that can read the query from the user and can translate it, let's say, into action. So here there is a long query in order to create, let's say, a scene. We ask from this AI module to create an area 10 by 12 meters, to enclose with fences, to create safety zones with specific dimensions and sizes and design, to put tables inside, to put robots, to put the parts on top of the tables, to put the screws or the tools in the different areas, and also to place a safety eye to check and monitor the different zones. So we give this information to the algorithm. The algorithm has been trained and has the knowledge, as mentioned before, in the background to understand this query. It processes in the background and generates a JSON file that contains, that you can barely see here, and contains all the information of the scene. And then there is a processor, and we click the process button that translates this JSON into a scene. So all the fences, the zones, the parts, everything is placed in the position and have the size of as they have been defined inside the JSON file. And of course, we have the opportunity to provide changes in the scene, either manually, as you can see through the inspector of the Unity project, or to provide a new query. The algorithm has the capacity to keep the knowledge, let's say, of the existing scene, what it did in the previous. So we give new instructions to change the size or to remove the fence, for example, as we are saying here, because we want in the three sides to have fences and so on. So when we again execute the, again, we generate a new JSON file, and when we execute it, then we have the new scene created. Moving on to the next technical development, this is on the robot programming side using programming by demonstration techniques. We can interact with holographic virtual robots, which are digital twins of the real ones. The approach is no-code programming to have a natural communication either through speech or by having intuitive interactions, touching the virtual robot or using the controllers of the headset and so on. And again, here is sophisticated architecture that enables the communication through ROS with the real robots. The AI part of this equation, let's say, is on the machine vision, that the virtual robot is able to use a virtual camera to detect objects in the scene and also to have some voice dialogue. And I'm going to show you a video. I hope you can also hear the sound. Here you can see the user is using this ball as a new position, and the system asks what?
Plan a trajectory.
Now the user says plan a trajectory. This is a
valid
voice
plan has
instruction.
been successfully calculated.
And here we can see the robot
Execute the plan.
making this plan, showing virtually how the robot
Executing
will
the
move.
plan path.
And following a voice instruction, then the robot is doing the real movement.
The plan has been successfully executed.
Find centers of washers.
And then the user asks to find the center of
Looking for features in the image.
Using a virtual camera, we can see here a few washers. They have been recognized. You can
Move
see the
to the
numbers.
center number 2.
And here is the number 2 washer. The system is recognizing the position.
A valid plan has been successfully calculated.
Generate a new plan. And first you can see the shadow of the robot moving. And
Execute the plan.
if the human is happy with the result, then instructs the robot to execute
Executing the
this
plan path. The plan has been successfully executed.
Okay, and moving on to the last technical development, this is the gaze-based interaction features. We have again here different users. There is the content creator that needs to set up the XR scenes using using gaze-based interaction. We have the trainee that again needs to interact with the virtual scene using their eyes. And then we have the trainer, which also, apart from interacting inside the virtual environment, we should be able to monitor how they perform and scan their visual, let's say, behavior. So the features of this module is the gaze-based object selection. We can have menus that we can select with our eye gazing to track where the trainees are looking and for how long, and to have some IML to do some fine-tuning detection of the modules. And here you can see another video. Let me start. Here you can see the full camera, let's say, feed, and here you can see what the human is seeing. This is a pre-trained model, so the system can recognize the different parts that are inside the field of view, the laptop, the pot, the book, and so on. You can see also the percentage of confidence. And then we can use information in order to answer questions like how the trainees, how much time they spend looking at an object, what attracts their attention, if they recognized all the objects in the scene, and so on and so forth. And last but not least, we also have an interactive annotation tool. So in the background, here you can see a screenshot of this annotation tool, the user interface. So in the background, we can train this module by adding new parts. So here with the different letters, you can see an overview of this IML support, the features that this IML support tool has. There is a status bar to indicate the number of AOI suggestions, the optical inspection suggestions that we want to have, and to have a specific level of certainty and trust level. Also, there are already some indicators here about the objects that have been detected. Here, we can adjust a bit the indicators inside the field of view of the user. And of course, there is the capacity to confirm that what we are seeing, the object we are seeing, is the correct one and put the correct label on top of that. So that's all from my side. I cannot see the WebEx screen, so I'm not quite sure if there are questions. So John, can you help me a bit on this part?
Yes, thank you, Panagiotis, for the presentation and for keeping the time, actually.
No problem.
Let's open the floor to questions to Panagiotis. Are there any questions to Panagiotis in the chat, or feel free to raise your hand and ask a question? Any question to Panagiotis and Master Project?
Maybe I can stop sharing so I can see you as well.
So, Panagiotis, maybe you'll be around for thanks.
Yeah, for sure. I will be around until the end of the webinar. So
for the end of the webinar, thank you for the presentation. Remember, everything is recorded, so we will be sharing with more people, and we will be sharing also your presentation, right, in PDF. So let's move on to the next presentation. And Nikos, Dr. Achillopoulos.
Yes, hello, I'm here.
The floor is yours. A lot of portfolio. Feel free to introduce yourself, introduce your projects, and take the time to share the presentation. And the floor is yours. Thank you.
Okay, thank you. So thank you, John. I'm Nikos Achillopoulos. I work for Majoli. Majoli is a company, a group of companies located in Italy, Spain, and recently we opened an R&D section in Greece. Majoli is well known in Italy, especially for serving the public bodies, municipalities and regions. We're also very famous for our police software and also as a publishing house, but the company constantly enlarges, and we have heavily invested in AI technologies for all our products. And at some point, we managed to get into the XR because of training. And today I'm going to speak a little bit about how we combined AI with some XR solutions by participating in 2 projects. So let me share my screen. I hope you can see it. Is it okay? Can you see the screen?
Yes.
Yes, Nikos, we can see the screen, and we can hear you very well.
Okay, so basically we, as I said, we got into, our primary investment was in AI, but at some point, due to training, we started doing some XR things. And we created a training program for firefighters, which is installed at the airport in Athens and airport Berlin, which is a training tool using XR. So we tried to enhance a little bit the work we're doing that, and we participated in 2 projects. The first one was Vox Reality, which relies a lot on speech and audio and using the voice. And recently Motivate XR, which is in the same, let's say, action as XR25 John presented. So I'm starting to talk a little bit about Motivate XR. I'm going to be a little bit let's say more not in detail for the projects, but more talk about the goals and the use cases and leave some room for questions. So basically in Motivate XR, it started 2 or 3 months ago. It's working on creating an XR tool suite for training, assisting industrial operations. So the use cases are all around assembly, manufacturing, maintenance, dismantling, etc. And it's a big consortium with 17 partners, many French, Italian, and Spanish companies, but also 2 Greek use cases and a Greek partner, and have success doing the dissemination, and especially TU Delft It's an extra part we have in the project who are doing the social science and humanities work. Our ambitions in the projects are to make digital twins easier. So we'd like to see the cost of an experience related to 3D equipment used in digital twin applications being lowered and make more accessible. We're working towards creating, let's say, an XR authoring tool that can be easily used by people not really into this technology. And we want to enhance this with a knowledge transfer to XR experience by using AI. Basically, this is about automatically converting technical documentation into XR content. And on top of that, we want to create some collaborative industrial XR experience. And in order to showcase this, I'm not going to talk about technology today at all. I must say that, again, we have an SSH expert who is on top of that and across all the use cases who wants to use the ethical and discuss about the principles of ethical use in XR and AI. And we have 5 use cases, and this is one in aerospace, in home appliances, in aluminum, in energy distribution, and human robot manufacturing. So give you a quick view. The first pilot in the aerospace industry is run with 2 partners, 2 use case partners in France who are servicing airplanes. So here we have a situation where we want to automate the conversion of technical documentation into digital mockups and maybe at some case start only from the PDF of simple manuals. It sounds very, very challenging. It is very challenging. The second case we have is Hisense. Hisense is a very well-known home appliance manufacturer. And in the case of Motivate XR, we will try to create a self-repair program, let's say, for people to use at home for repairing a washing machine. So this could be then easily expanded into other devices as well. But in this case, which we will try to make an XR experience, maybe a metaverse experience, let's say, for simple people how to repair a dishwasher. This is usually done at this point. Many people are trying to fix things by themselves. So they're relying on YouTube videos or some documentation they find on the internet. So Hisense is very keen in providing for free something in the metaverse, let's say, for the devices. The third case we have is in the aluminum industry, and for this we're using Alumil. Alumil is a very big exporter, one of the biggest exporters, producers of aluminum in the world, actually. And they have an architectural academy in Thessaloniki in which they train people how to assemble things. And this experience is sometimes needed in countries like Saudi Arabia, India, and other countries. So it's for them very interesting to have a very good, let's say, educational tool to even support remotely the assembly, not only teach, but also support the assembly remotely. The fourth case is Hedno. Hedno is the distributor of energy in Greece. So basically, it's the power network, it's the cables and the pillows. So, and these people are really interested in training, upskilling, but also supporting technicians who are on the roads. And for that, they're interested in having augmented reality to support information and digital functionality. And the last case is a human robot hybrid manufacturing case for which we have Birex in Italy. Birex is one of these DIH, Digital Innovation Hubs, and a Big Data Innovation and Research Excellence Center. It's really, really impressive. If you ever visit it, it's in the Emilia-Romagna region in Italy. So it's close to Majoli. And they have this human-robot, let's say, interaction in manufacturing, supporting the industry. And in this case, they want to have some training and support the workers to interact with equipment via XR technologies. So these are very, very challenging use cases. So we have 7 components that are going to be developed. One that is very important is we have a videogrammetry scanner, which is a company called 2F, and this is going to be enhanced in the project. For digital twins, we are going to use platform developed and operated by Majoli, which is called Mira, which is available now at several locations around Italy and Europe. For the AI-powered documentation conversion, we're going to rely on the French technology of Soprasteria, which is also a very big group in France. And CS Inkscape, which is also very experienced in defense and airplane applications, has a tool that is called Inkscape, which is going to be used for no-code XR authoring. In terms of ubiquitous no-code XR authoring, we also have Kairox, which is a tool supported by Tecnalia in Spain. And for headsets, we have a headset company inside the project, but we're open to use other headsets as well. But in this case, we're using a ubiquitous Leonardo headsets. And in Thessaloniki, we have the Cube, which are giving to the project a remote training and assistance tool. So basically, this is the most things you got out of Motivate XR. So I can move on to speak also a little bit about Vox Reality. How much time do I have, Yanis, John?
We are a little bit out of time. It's not your fault, but please,
Okay, very quickly. Vox Reality again.
Will be appreciated, Nikos.
Yeah, okay. Vox Reality again is a project that is halfway through already. So you're going to expect a lot more to see in the recent times. So the basic idea is that we have natural language combined with computer vision to give solutions. So we want to improve human to machine and human to human XR experience. Use the language wherever we can, even for navigating, not only for translation, but also for translation, but also create models to extend and improve the visual grounding of language models. So this consortium has also very interesting use cases. We have 10 partners out of 5 countries. Majoli is again coordinating this. And we have 3 use cases, a virtual reality conference. This one is one I'm very proud of. It's the augmented reality theater. And we also have an augmented reality training assistant. So what this is all about, so imagine you have AI models for automatic speech recognition, for neural machine translation, for visual language models, and conversion agents. And these are all used for these 3 use cases. So in terms of virtual conference, you have translation, contextual information, transcription, and online support facilities. Because you create somehow a virtual personal assistant that allows you to participate in a conference via avatar or VR, or even through AR, use the headset inside the conference. For this, we have VR days on board. So this is what this is going to be tried. I think you know VR days. It's a very well-known conference every year. It's one of the biggest ones in Europe. So we're going to showcase this for this specific conference. They're a partner. In terms of theaters, we're very proud to have on board the Athens Epidaurus Festival. Here we have contextual information, translation, and transcription, but imagine a play in a very old theater or even a new theater, it doesn't matter, that is enhanced in the easiest part with subtitles. You can watch through your glasses. And in a more extended part, we have visual effects that are visible through the glasses only. And in the third case, we have a personal assistant that is used when you try to train factory workers in industrial assembly tasks. Here you have also the online support thing again. But I think this is really worked on by HoloLight. They're very experienced on that. So I think you have HoloLight also in XR5, John, if I'm wrong. So there are very distinct challenges. Example in the theater, which is a little bit cultural, let's say. We started talking about automatic subtitling and automatic translation and things like that. So imagine you have people in the theater looking at the theater play and wearing the glasses and seeing the subtitles. It sounds easy, it's not, because you don't want to distract the people. But imagine that you can have a digital experience with effects inside the glasses that are not visible for people without glasses. So there are many challenges in all these use cases. Even the fact that we're using 6 languages for this and the AI to support this is, I think, a very innovative factor. So that's it. Thank you for these 2 projects. If you have any questions, I'm happy to talk about it.
Thank you, Nikos. A lot of content. Let me ask if there is any question, either in the chat or somebody wants to ask something.
Somebody has raised his hand, so.
Yes, who has raised his hand? Feel free to.
Hello, John. Hello, Nick. Thank you for the presentation. I'll make the questions very quick. Digital twin, could it be used to authenticate individuals' identity, especially given the high mobility of citizens? And my second question is on right to repair. So perhaps do you see your product expanded to other companies besides Hisense, given the EU regulations of consumers having access to the right to self-repair? Over.
Okay. The first question is, I'm not sure yet how this is, how the identification process goes along. We're currently in the stage where we finished the user requirements for that. And it turned out to be more complex than we thought. Because especially in the case where you want remote assistance, you have outdoor and indoor case. Certainly you have a way of identifying who the worker is. The problem we have is identifying his exact position, I think. But nevertheless, it's been worked on. Yes, it's we're on track on this concept. Now, regarding the fair use of the free repair, what you're saying. So at this point, okay, we're trying to see how this works out with Hisense. Okay, it's very new, and they are very keen in providing this. So we haven't talked to any other companies yet, but I think once this is out and it's advertised, it's going to raise some interest, I believe. Basir, if you can hear me, this also has to do with what companies are doing in Europe. So Hisense in Slovenia, so it's they're closer to the European thought, let's say, of repairing things. So if some other countries come along with their equipment, I don't know if they were forced to provide something like this. I don't know.
Thank you very much. It was a great set of products. I'm looking forward to hear more. Thank you.
Bashir is into the security, and critical infrastructure protection. So maybe in one of the next webinars, we will cover extended reality for this specific sector. Yes.
I would love to join crisis management, combating hybrid warfare, all of those things. But it's just, so I'm very glad to be in this wonderful group of people. Thank you, group of scientists.
Thank you. And having said that, we need to move to another sector, which is education. Is actually, one of the champion sectors for extended reality. Let's see how artificial intelligence can play a role there. And I'm going to give the floor to Dr. Professor Fotis Liarokapis for the first presentation representing XR 4ED project. Also with Nuria Perejano. Fotis, the floor is yours. Feel free to share your presentation, introduce yourself and your project.
Hear me?
Yes, we can hear you. We don't see any presentation yet, but I think you will be sharing it. Yes.
Give me a second. What about now?
Yes, we can see the presentation. We can hear you.
Thank you for the invitation. Thank you. It's a pleasure to co-present this the work that we're doing on XR4D project. I'm the coordinator of the project, and I'm going to co-present it with my colleague from Spain, Professor Nuria Pelechano. So I'll give you first a quick overview of the project. We are 11 partners. We have it's an innovation action. We're close to 8 million euros, and we have FSTP calls.
Sorry to intervene. Your sound became low suddenly.
Can you hear me now?
It was okay, but when you started speaking, your sound became low. Maybe you can.
Yeah, I will restart. Okay. We're 11 partners. It's an innovation action, and we have a budget close to 8 million euros. We have just finished the launch of the FSTP calls, and we have awarded 20 successful projects. Half of them are in concerning developing tools for the XR4AD platform. The project is about building a platform, collaborative platform for all levels of higher education. And the other 10 projects are about creating pilots. So we are going to give out in the next few weeks 4.6 million euros to these 20 successful projects. So as I said, the plan is we have a beta version at the moment of the platform, which is going to be open to these 20 projects. After the project is finished, we're going to make the platform open to the public as well under different types of licensing. And the main concepts that we have is we have a game authoring tool, which is basically for teachers who don't know how to program. We're using Unity as the main platform, but the idea is that people who don't know how to program, like teachers, educators, are going to use the authoring tool to create their own teaching lessons, teaching scenarios. The second thing that we have is a developer platform, which is a web-based application which is used to integrate third-party tools. And finally, this is the work that you're going to see from my colleague, Nuria Pelechano, about avatars, which are used in XR environments for education. The other interesting thing that the project has is a marketplace. So anybody who's a third-party developer or anybody who's working the project can upload their own material, which could be 3D information, metadata, images, videos, and we can have, again, different licensing methods. The marketplace offers this unique opportunity for having a repository for education. As I mentioned, it covers all levels of education, from schools to university level. And I will show you some results. I will start with my colleague, Nuria Pelechano, will jump here.
Hi, can you hear me?
Yes.
Okay. So what we're doing for this project, besides what Fotis just explained, is that one very important part when it comes to interacting in virtual reality, especially when it comes to education, is to be able to communicate with others in a natural way. And in order to do this, it's very important that we bring non-verbal communication into extended reality so that we can express things with our hands and our body motion. So the work we're doing at UPC attempts to bring this non-verbal communication into the collaborative virtual world, with the purpose of achieving embodiment, which has to do with the feeling of your virtual avatar representing yourself in this virtual world, and also achieving presence, which is the feeling of being in the virtual space and feeling the virtual space as if it was the real space in which you're located. So with this work, we can move for this to the next one. Yeah, just press play over the video, please. Thank you. Okay, so here is some of the work. This is just a dancing kind of joke from my students, but the idea is that with a few controllers, with the head-mounted display, handheld controllers, and possibly a few additional trackers that we can locate on the user, we can have the virtual avatar moving around the virtual world exactly as we would be doing in the real room. So in this, you have a very simple example where you're simply using inverse kinematics so that the avatar can follow the movements of the user. So if we are talking about any 3D concept that requires pointing at something or requires making a gesture that indicates the size of something, we can bring this part of this very valuable part of the communication into the virtual environment. So here what you see is an overlay with a head-mounted display of the real room with the virtual avatar. And some of the problems we are solving in this work is, for example, how to deal with the discrepancies between the dimensions and movements possible for a real human compared to those that the virtual avatar has available. Because at the end of the day, the virtual avatar it's simplistic representation of a human skeleton, and the dimensions don't always match perfectly the user. So there are certain mismatches, like the ones you can see here, where the controllers appear to fly away, that we need to solve in the for the purpose of having these avatars representing us in the virtual world. So with this, you can see a little example of how this could be used in the classroom. So people could, it's okay, but next slide, okay.
Right.
Basically, it's okay. You could see that two people could be in the virtual world. They could be drawing in a virtual blackboard, and the other person could be seeing those things in real time. So some of the challenges that we're dealing with as part of this XR for Education project is that there are many different types of head-mounted displays, and we need to be able to handle that the platform can work with any of them. There's also the importance of having good animation fidelity, regardless of the type of input trackers we have. So here you can see in the center an image with the XN system, which is a system that uses many sensors over the body to capture highly realistic animations. However, we're working in the videos you saw before with just 6 trackers. So we're trying to replicate that quality of animations with just 6 trackers. And even if we move to the next slide, even for the case of having even less trackers, so how are we using artificial intelligence in the context of extended reality in this work is, can we learn from real human data in order to then replicate natural human movements when we don't have enough input information? So for example, here you can see that wearing only the head-mounted display and at most the handheld controllers, we can replicate animations for the virtual avatars that are a close representation of what the user is doing. So this is, the idea is that when people use this technology at home, they can have natural animations, even though they don't have as many trackers as we were seeing in the more complicated systems. And this basically combines artificial intelligence to predict the body orientation from just 3 trackers with a technique based on motion matching, which basically gives you the best locomotion for the legs based on a large database of animations captured from real humans. And moving even further, the next work we will be seeing in this slide, won't go into detail, but the idea is that for this work, having just a few trackers and using convolutionally based autoencoders, we have encoders to encode information about static data, about the human body, and dynamic data about the movements the user is doing, with decoders that then generate a sequence of animations that look smooth. And the idea is, once again, use artificial intelligence to learn from real human data to then replicate this non-verbal communication in a natural way when having just a few trackers. So this is mostly the work we're doing on avatars, so we can bring this very important aspect into virtual communication for the purpose of teaching a class, for example. So with this, I think you can continue. Okay.
Thank you very much, Noria. So the platform has, apart from the avatar, the extended reality platform has 2, let's say, main components. One is a VR component, and the other one is an AR component. I'm going to present you an intelligent XR assistant, which is combining both AR and going towards mixed reality. So the idea is that we're using the avatars that Nuria just mentioned, but also we're using other information, multimedia information, which is as I mentioned very briefly, it's located on the marketplace. So the teacher can get into the marketplace, collect the information that he or she wants, could be presentations, panorama images, sounds and videos, and the avatars. And then using artificial intelligence, we're using ChatGPT and extended reality, we can start superimposing, as you can see from the screenshots here. I'm going to show you a couple of videos in the next few slides. So one of the things that we focused a lot was we wanted to make the representation of the humans, apart from the work that Nuria is doing, to have avatar gestures and animations, and we integrated the other multimedia content that you saw. We also have speech interaction and multilingual support, which comes from ChatGPT. And also, we have developed our own way of having animation on eye and gazes and head motion for avatars. So you can see on the left-hand side a traditional commercial solution, and on the right you can see our solution. This is the solution that has incorporated into the avatars that we're using for the intelligent assistants, and it's working on real time. This is focused on at the moment is focused on Android operating system. So we're using mobile phones, tablets, or we're also using Magic Leap as the more heavy and the more immersive AR headset. So you can see this the eyelid also animation, which believe it makes difference when this information is exposed to learners, which covers from primary school to university levels. So this was incorporated, and the other part that we have done is we managed to make this application to be collaborative. So you have a collaborative AR/XR application. And I'll show you two videos. First of all, here we have created a scenario where the teacher has uploaded his or her PowerPoint presentation. So ChatGPT at the moment is interpreting the slides. It's working real time. You see this ball moving above the head. And of course, the user can ask any question that he or she wants. Obviously, this is limited to the capabilities of ChatGPT. You can see some of the animations, the gestures. In the other example, we experimented with something different. We use the first video was done in a laboratory environment. The second video is the same, but in order to give the illusion that we are not in the laboratory environment, we're using panorama images, which are 360. So now, although the video was shot in the laboratory environment, like the first video, we have the impression that we're in the city center of Nicosia. We give a topic to ChatGPT about the city of Nicosia. So this is more focused about cultural heritage. And we have two avatars, which are in the beginning speaking together and explaining something about the history of the place. And at the end, the user again can start asking some questions. So here you're going to see the user is asking some questions. No. So the user is now making some questions, and ChatGPT is answering in real time. So this is just an example of how we can use AI in different modes on a single, let's say, avatar mode or multiple avatars modes. Last thing I'm going to present very quickly is we have primarily piloted the application in 3 different occasions. The first one was done in science, where I work in Cyprus, where we invited teachers. The second venue was in Immersive Tech Week 2023. And finally, so it was done with XR professionals. And the final venue was in Eurographics. I co-organized Eurographics with Professor Chrysanthu. So we had the researchers, computer graphics, mainly people who are aware of XR. And we got some positive and negative feedback. At the moment, we had a small sample. We're going to, as I said, we have 10 projects. We're going to pilot that with big samples from different types of educational background and institutions. So this was indicative feedback that we received, and we're going to be improving the platform the next month and perform a full-scale evaluation in both laboratory and through the pilots. That's it from me. Thank you very much. We're happy to take any questions if there are any. Thank you.
Thank you very much, Fotis, and thank you very much, Nuria. Very nice presentation in a little time. May I ask if there is a question now for Fotis and Nuria, or otherwise we will wait till the end, to the end of the webinar. And we have, are there any questions? Anyone wants to raise a hand or to ask something in the chat? No? Okay, I may ask you things. Let's get the presentations done first, Fotis, and have the discussion in a while.
Thank you.
Andromachi, this is your turn. Last speaker for today.
Hello to everyone. Let me share my screen.
We can now see you, we can now hear you.
I fixed it.
Very nice. Please share your presentation and feel free to introduce yourself, your project. Thank you very much.
I think that you can see my screen now.
Yes, now your screen starts appearing. Not yet projected 100%, but we can see something coming.
Are we good to go?
I see a white screen. Don't know why. Can you share once again?
Let me try again. Can you see the presentation now?
Maybe you can you switch some slides or?
No? Let me try something else. Can you see my screen now?
At least I cannot. I don't know if. Is it okay if I share this for you?
No, because this is not the last version.
Okay, okay.
I made a lot of changes. Sorry.
No problem. I just wanted to help. Previously, when we tested this,
We didn't have any problem, yeah. So you cannot see my screen, whatever I'm doing.
I cannot. I don't know if anyone else can see the screen. Can
No,
somebody?
it's just white.
Just white.
Yeah, just white.
We can use the presentation that I've sent you. It's okay.
Yes, and you give the last version, right, for sharing. Okay.
Yeah, I will.
Thank you. Just instruct me to change the slide, okay?
Okay. So hello to everyone. I'm Andromachi Filippidi. I'm a teaching staff in the Department of Educational Science for Early Childhood Education at the University of Patras. Vasilis Komis, who is appearing in the presentation, is the scientific coordinator of the Mentor project. UPatras is a partner of a bigger consortium that we work on Augmentor. We as a team, UPatras team, we are responsible for the pedagogical framework of the Augmentor project. So let's move on to the next slide. I'm gonna give you a brief presentation, first of all, of the Augmentor project, and then I'm going to give you some details, not in depth, considering the pedagogical framework that we are using for the Augmentor project. This presentation is a bit different from the others because we're the pedagogical partners, so you're going to see a lot of work that we're doing behind the final AI solution that the whole consortium is designing. So I'm gonna give you some details about the levels of the Augmentor pedagogical framework, some theoretical foundations, the activity that we are using as the unit of analysis. I have added some slides that they're a bit important. I'm not gonna be able to present them, but I'm gonna describe them. And finally, I'm gonna give you a brief description of how this pedagogical framework is gonna work in actual terms. Let's go on with the next slide and the next. So, Augmentor is a European project, is an Horizon project. For this project, this is a project in education. The main goals, besides to create an AI solution, had to give a lot of effort to ensure how we're going to inclusive quality education and promote lifelong learning. We need to develop personalized and collaborative learning. We have to leveraging emerging technologies into education. So the half of the project is about the educational needs and the educational framework of the final AI solution. Through using educational data mining and learning analytic techniques. So let's go on to the next slide, please. Okay, this is let's go on, let's move on because we're out of time. We're trying to move from technology rich to technology augmented education and training. Education and training is about the pilots that we are testing, the augmented solution that we have already designed, because the project lasts for 3 years. We're in the last year of the project, so we have designed something and we have already try a lot of things in our pilots. Our pilots are in secondary education, in tertiary education. We are running a pilot here in Patras, and we have a pilot in adults, and we also have a pilot from a partner from Greece. It's EASIS, which is on lifelong and learning education. So let's go on to the next slide. And this is what we're trying actually to achieve through, actually we're aiming to learners, to teachers, to parents, to policymakers, and to educational leaders. We're trying to create and collect educational data in order to train our AI and ML pipelines. We're using knowledge graphs in order to create these pipelines. In order to, because this is the main object of the project, to design, test, and actually propose methods for assessing 21st century skills, and by creating and proposing dynamic learner profiles. Here you can see the way that the consortium works. We are under work package 3, the educational, the pedagogical framework for emerging technologies. And as you can see, we have to collaborate with the rest of the consortium in order to propose something that's going to be useful and not only theoretical. So let's go on to the next slide, please. This is the consortium. We're partners from Greece, from Cyprus. We have a partner from Austria. We have a partner in Lithuania, and a partner from Serbia. So let's go on. What is the augmented pedagogical framework? We did a lot of work in reading the literature, and we identified a lack of pedagogical frameworks in the literature that actually fully meet the needs of the project, because we saw a lot of theoretical work going on, but they only used some pedagogical aspects partially. So we had to propose a new pedagogical framework, actually focusing on student and teachers' activities when they're using AI. This framework actually built on models like ADDIE. If we have some pedagogical here scientists, they're very familiar with that model. But we had to distinguish between macro theoretical and micro classroom level using activity theory for analysis of the design. Under this project, we managed, besides the proposal of the novel pedagogical framework, because we built it from scratch, to extend the very well-known pedagogical framework, the TPAC framework, which now called from the UPatras team TETPAC, which includes emerging technologies and specifically AI for teacher knowledge in teaching education. We also proposed an actual classroom level micro data-driven model, the technology augmented educational scenarios, which can be used by teachers, by course developers, and for the project, this data-driven model is used by the technical team in order to communicate the data that we're collecting through the pilots in order to build the ML pipelines and actually design the augmented solution. Let's go on to the next slide, please. Thank you. And now some details for the pedagogical framework. So the pedagogical framework comports of two levels of abstractions, of abstraction. The first level is the macro level, as I said before, the theoretical foundation. And the micro level, which is the augmented educational scenarios and e-activities that we are proposing for the consortium. Let's go on to the next slide. We call the macro level PEDMET and the micro level TESA. We have the theoretical foundations that we went through. We used enriched pedagogical triangle by emerging technologies as our basic learning approach. We used the TPAC design model for trainers and tutors that we extended to TEDPAC, and the activity theory as an analytical and perspective model. These three basic foundations actually give us all the information for the PEDMET, the macro level, which gives us all the information that we need in order to design, create, and implement the TESA framework, which is the actual guidelines for the teachers and the technical team to implement the course design and the pipeline design. Let's go to the next slide, please. So this is the first very basic theoretical foundation that we have used and again extended. This is the pedagogical triangle, actually pedagogical design with digital technologies is a new model for designing, teaching, and learning. At the theoretical level, the design takes into account the findings of the modern learning science in combination with those of educational technology, in our case, because we're using technologies. Besides AI, we're using a lot of technologies in order to integrate them into rational design of teaching and learning. Here you can see the extended pedagogical triangle, which is proposed by UPATRA's team, that we have added a lot of technologies. Actually, this didactic or pedagogical triangle is a key theoretical concept that we use in learning science to describe the dynamic, as you can see, relationships between learners, knowledge, and tutors. As you can imagine, when we're using this theoretical foundation and we enrich this triangle with technologies, even if we are talking about simple technologies like educational softwares or LMSs, or AI, or the augmented solution. Finally, we are concluding in very different relationship between those three that are the actual actors of the educational process. Let's go on, please, to the next slide. Next. Okay, this is how the other theoretical foundation works in our augmented pedagogical framework. This is the extension of the TPAC to the TEDPACs. Here you can see the three basic nodes that a teacher needs to be comfort with when he or she is in the teaching process. Here you can see the content knowledge. So when we are talking about physics, you need to know the content of the physics in a level at least. You have to have pedagogical knowledge, all the information we need about the educational sciences. and which models we can use when we're teaching. And finally is the technology. In our case, we extended because we're using AI, specifically in learning management systems. So basically, in our project, we are designing and implementing an AI solution, which is going to be used in very well-known platforms as Moodle. So we're creating courses in Moodle based in this pedagogical framework. And this, the solution that we are designing is gonna be as an API in Moodle for sure, and other very well-known platforms in order to enhance the work of the learner and the teacher. So let's go on to the next slide, please. And this is the third and the final theoretical foundation. This is activity theory. We use activity theory not only to analyze, because it's a very well model to analyze the activity of the learning process. We used it as a basic theoretical foundation to design our pedagogical framework. The learners and the tutor activity is the basis of analysis in our case. Let's go on to the next slide. So this is the macro level of our pedagogical framework, the PEDMET, Augmented Pedagogical Design Model with Emerging Technologies. Let's go on to the next slide. Okay. So this is the whole PEDMET. This is all the foundations that we have used, and the combination of these theoretical foundations are represented here. As we have said, the activity is the main unit of analysis, and in this chaos, actually we're trying to achieve that our model, among other things, must first of all analyze the needs, instructional and cognitive, of the subjects in question and in relation to the activity they are going to perform. This model has to describe appropriately the school content, object, and the activities of the students, of the learners. This model actually has to focus on the ways of using the tools, physical or symbolic tools, that mediate these activities. Technology, digital tools is a basic tool that we're using to this activity, to identify the results of teaching and learning, to identify the teaching and learning strategies, including the strategies related to the 4 Cs, because this is a major challenge for our project to actually integrate the 4 Cs in the course design, in the augmented solution, and the assessment of the student, to describe the formative and the final assessment procedures for both learning outcomes and overall activity, and actually place the teaching and the learning activities in a wider school and social context in which they develop and affect the learners and the tutors of the activity. So let's go on to the next slide. And now, finally, the micro level, the TESA level, is the law-based pedagogical framework, is the actual guidelines that the tutors, the course designers, and the technological team is using in order to design the courses, in order to map the data that we're collecting with the pedagogical framework that we have already proposed. Let's go to the next slide. Okay, so the next slide as well. In the next slide here, we can see the presentation of the TESA framework. As you can see, we have combined all the theoretical foundations that we mentioned before into really easy steps for anybody who wants to design a course by using AI in order to collect data and have some assumptions and conclusion. The next slide. We can see the difference and the main goal of the project on how we're going to integrate the forces in all this procedure. We have, this is a novel component in the literature. We are actually proposing for each course that it is using technology and specifically AI to blend e-activities with all the activities that they're going on in the classroom. And this is the types of activities that we have to create in order to collect the appropriate data. In the next slide that is not in this presentation, it is in my presentation, we have created a small graph which describes the way that the pedagogical framework actually interacts with the collection of the data and the creation, the design, and the implementation of the AI model. The basic idea is that we're using all the information that we are collecting from the Moodle, since we have designed the courses on Moodle based on this pedagogical framework, in order to feed the augmented solution with the appropriate data. For the augmented solution, to use a series of indicators in order to provide to the learners and the tutors with appropriate recommendations, feedback and recommendations to change their educational goals, the learning experience, and help them engage in the process in a more holistic way. These recommendations are personalized because we're using different data and different pipelines for each learner's profile that the solution is proposing. For this, we are collecting data and we're using learning analytics and learning analytics processes to create these recommendations. I think that's it. Okay, thank you. Sorry for not the last version, the final version of the presentation. I will share it with John and share it with the rest of the people. Thank you.
Thank you, Andromaki, for the presentation. I have a question, and then we can take any questions from the audience to your presentation, but also to everybody's. But for you, because I'm not really familiar, with all these user methodologies. Is there a method to audit the educational system in terms of the added value of AI or extended reality or virtual reality? So the question here is, if I have a technology-enabled learning system, right, which has different features, right, in learning, personalization, AI, etc., how do you really account, for the added value of one specific technology? Is there a methodology for this, or each time you have to think, how you compare?
So basically, this is not a pedagogical question, but it's a very good question. There are some tools that we've used for this project in order to evaluate the systems that we are going to use and extend. There's certain methodologies that we're using in order to make the appropriate decisions, because you cannot decide that I'm going to use Moodle maybe, or design an AI solution to support learning and teaching process without having approved tools from the community. So yeah, there are a lot of them. We used not in this work package, in work package 2, which was the technical and education requirements in order to conclude to an appropriate solution. I think that all the deliverables from Augmented project are public. So
okay, that's good.
share with you whatever you want. Yeah.
That's very good to know. Okay, are there any questions? Yes, I can restart the recording. No, I think it still goes on. But I wanted to ask if there is any other question to the speakers. And in the meantime, I want to say that this is the first webinar of a series. So we will have more webinars. Next one will be in November, and we will cover different topics related to extended reality, like personalization, like issues which are, related to ethics and legal, regulatory compliance, safety. We will have a webinar on standards. So all of this will come, and those of you that are part of this webinar and also registered, you're gonna for sure receive this information as a matter of priority. So I don't know if Fotis and Nuria is still online. One question I had on this presentation is, what is the application of learning from the human motion? I mean, today most avatars are not teaching you based on motion, right, Nuria? It's like an avatar which is just reproducing text, right, or reproducing information. So motion doesn't matter as much unless you go to things like maybe rehabilitation, maybe fitness, and so on. So what is the intended application, right, of this, right, of learning with the human motion, and where we can find today avatars like this?
Okay, if I understand your question correctly, of course, human motion is needed, as you mentioned, for applications like where you want to show somebody how to dance, or even do rehabilitation, for example. It's a very strong application area. But it's not only that, it's also the fact that we humans, when we have a communication with others, we use non-verbal communication. And this means even facial expressions, but it also means how we move our hands. When we are referring to something, we point at things. We use gestures to emphasize, for example. So this is a valuable part of communication, that if you were in a classroom, for example, getting only text, you're getting the content of the class, but you're not getting any part of the information from the teacher, maybe what parts are more important, or even aspects like, if I'm explaining something that involves the 3D world, so it's not just something that is on a blackboard, but I am in a, let's say, in a large environment, and I'm explaining a class on architecture or painting, and I want to point at different things, and I want to indicate things with my body's movements. I want to be able that my self-avatars are replicating that movement as accurately as possible. Even small things like things we might not be aware of, but when you're communicating with others, you are, in a subconscious way, you're paying attention at their non-verbal behavior. It gives you information about whether they're confident on the things they're explaining to you, for example, or whether they're nervous, or whether it gives you the feeling they know well or not what they're talking about, for instance. So all those elements are currently missing when we just use an avatar, that it's not moving at all, or it's just very robotic, for example. Is that what you wanted to know?
I understand. The question is that myself, as an instructor, have good and bad body language, right? So sometimes my body language is very confident, very perfect, very caring, good emotional intelligence. Sometimes I'm weak as an instructor, right? So your intention is to learn also my imperfection so that the interaction is humanized, or to create the perfect tutor, because the perfect tutor is confident, is caring, is personalized. So this is, what I didn't understand, because I think the applications that Fotis presented, I think they don't have this body language, right, incorporated. So, but your goal is to create a perfect, in education, a perfect instructor, or a humanized instructor, which in some cases is imperfect, right, as well.
Okay, so our goal right now is only to be able to replicate as nicely as possible, as naturally as possible, what the user is doing. That is as a research objective, okay? Now, your question is more complicated, and it involves also ethical aspects, no? So it's very important also in the sense of interacting with others in virtual worlds, because as you're saying, not only as a teacher, but in many other types of communication, there might be things we want to hide, or we want it not to be so obvious that we are nervous when we are in a
negotiations, sales, for
exactly.
example.
So that would be a different level where you could think whether we can create kind of filters for animations, for example. So I want to do this interview giving the appearance to the other person that I'm confident and that I can do my job correctly. And I want to hide the fact that because I'm nervous, I have maybe some nervous tick going on, or I have something that it's showing, I don't know, how much I'm blinking, that might show that I'm not completely sure of how I'm answering the question. So that's another aspect, is if we want to create the perfect instructor or the perfect animation filter for when we're doing a job interview, it would be another area of application. Like, as for now, our goal is
So the research is mostly mimicking now, right?
For now, it's mimicking. Now it's to make sure that like you're talking and as you're asking the question, you were moving your hands in the air, You're obviously expressing with your hands. I do the same. So I don't want my avatar, if he's teaching a class, if I'm teaching a class with a virtual avatar, I don't want the avatar to be robotic or to be doing just very strict kind of jumpy movement. I want it to replicate as naturally as possible what I'm doing. So for now, we're focusing on that research problem. Then how we could do different variants, different solutions to apply it with different goals. That would be, future work, I would say. Something to look into later on.
Thank you, Nuria. That was, what struck my attention, right, actually, in the XR4D presentation. I think we are almost on time. I would like to thank everybody, unless I see something in the chat, which I don't see. I want to thank everybody, especially the speakers. And just to remind everybody that we are going to share the recording and to share the presentations. We had 100 people registered for this webinar. Actually, around 50 plus actually attended. So first, all the registered people will receive the recording, and then also, because we have some project leaders here, bear in mind that the next seminar is in November. We will ask you for your kind content and kind contribution to give useful stuff to the community. Thank you very much, and see you next time. See you soon.
Thank you.
Thanks for inviting us.
Bye. Thank you, John.
Thank you, John. Bye-bye.
Thank you.
Bye.
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 Thank you. Bye.
Thank you. Bye.